Hi everyone, in this video I'm going to talk a little bit about anti-aliasing and upscaling methods in Unreal Engine, and specifically we are going to go over all the different anti-aliasing methods, either with built-in upscaling or no upscaling that comes with the anti-aliasing itself. I'm going to go over the Unreal Engine settings menu, how you could basically create like a video settings menu and what it should or should not contain. And we're also going to talk about custom anti-aliasing and upscaling methods, such as the quite popular NVIDIA DLSS, which also have a frame generation, a reflex, and other products included, and also the AMD version, which is the AMD FSR 3.1, which is the latest one that also comes with a frame generation tool. Now, basically, when it comes to anti-aliasing, Unreal Engine offers a few different methods that you can go with. You can either turn it completely off, and that would mean that you do not have any anti-aliasing whatsoever. You could, however, use one of the built-in anti-aliasers, meaning you could do something like a FXAA, fast approximate anti-aliasing. Now this does not come with upscaling, so it's just a purely anti-aliasing method. You could do something like a multi-sample anti-aliasing, which I think also does not come with its own upscaling method. This is again just a pure anti-aliasing method. You could do something like a TAA, in this case it's called temporal anti-aliasing upscaling, TAAU. So this one comes with its own upscaling, but the basic TAA, which is just temporal anti-aliasing, that does not come with its own upscaling methods. Or you could do something like TSR, which is a temporal super resolution, which is, by the way, the default upscaling and anti-aliasing methods used for anything above Unreal Engine 5.1. So at 5.0 or 5.1, Unreal Engine decided that they're going to switch from the old so far used TAA, not the upscaling, but temporal anti-aliasing, so just TAA. That's what being used for Unreal Engine 4 all the way. And then they switched over to TSR, so temporal super resolution. Now this one comes with its own upscaling method. Meanwhile, the other ones, obviously not the upscaling way, but the normal TAA, the FXAA, the MSAA, these ones do not come with their own upscaling methods. These are just purely anti-aliasing methods, okay? So, regarding each of these, there is a good explanation about temporal super resolution, about TAA with its own upscaling, the normal TAA, FXAA, MSAA. So every single one of them is nicely explained in the Unreal Engine website. We're not gonna go too much over it. There's always been a decade-old discussion about which anti-aliasing methods is the best or works the best. You can, however, include many different ones in your project, meaning if you have a low-end spec or GPU or CPU, you could offer, for example, FXAA, meaning that someone with a low-end set, they could choose that, or you could offer a MSAA at X4, I don't know. It's up to you from these anti-aliasing methods, whatever you offer to your end users. Now that's it for the anti-aliasing kind of main topic introduction. And now let's talk specifically in terms of like an Unreal Engine project. Now in Unreal Engine, if I go to the scalability settings, as you can see, you got your anti-aliasing method, which is in this case currently set to TAA, so temporal anti-aliasing. It's not the TAAS, which comes with its own with its own upscaling. This is the no upscaling version, just the pure TAA, which is just the temporal anti-aliasing. Also in Unreal Engine you have options like these options for graphics or so-called video settings, where you can set the particular values such as post-processing, anti-aliasing, shadows, global illumination, reflections, textures, effects, foliage, shading, and landscape to low, medium, high, epic, cinematic, or auto. And of course the screen percentage, which is the 3D resolution, by the way, you can set between 0 and 100%. Now this always been the kind of default video settings in Unreal Engine. That's why when you go to an Unreal Engine video game, this is most likely what you're going to see in the video settings as per graphic settings. Now, good thing to keep in mind that landscape itself came with Unreal Engine, I think 5.4 or 5.5. This is a relatively new stuff, so this has not been in previous versions. Landscape was not here, it was up to shading up until here. In Unreal Engine 4, I think it was up until the effects, and then in 5.1 they put foliage and shading into it, and 5.5 they put landscape into it. So now this is what we have. By default, usually when you download like menus, setting menus from marketplaces and such, they usually control each of these video settings, meaning that they are able to set each of these settings. So in our case, for example, if I would go into my game, I have my video settings where I could edit each of these stuff. Now let's just open our test map and I will show exactly what I mean by the menu and the video settings itself. So by default, as you can see, I'm using Hyper, Games by Hyper menu and Games by Hyper asset list. It's a really cool pack, so shout out for them. I am using their assets. So now that we loaded in, of course this was the first load, so it took some time, it's not gonna do this much. Let me go to the settings menu, and inside the video settings tab, that's what we created to control the video settings. We can see that we have quality presets, and if you set the quality presets, like for example medium, that will control every single settings and will set everything to medium. If I go and click everything to high, then it will set everything into high. Now, good to know that I took off 3D resolution and anti-aliasing from this menu point. So it used to be an anti-aliasing set here, and when you set the quality presets to high, medium or low, it also control the anti-aliasing method itself, and it also controls the 3D resolution. Now I took both of these off. Let me just confirm this. I took both of these off, and now the anti-aliasing quality and the resolution scaling are both inside the other tab, which is, I call it graphics tab, and I removed it from the default video settings fully because once you set a quality preset to, let's say, high, it's not gonna control the anti-aliasing method and the resolution scaling. So if I go out from here right now and I go back into the menu and I go here, I can see that the anti-aliasing kept on medium, the screen percentage kept on 100%, but everything else like view distance, post-processing, shadows, global illumination, etc. all changed to high. So basically, of course, not landscaping, because I have not integrated landscaping into the picture yet. It's a new feature and I just upgraded to Unreal Engine 5.5 and I have not finished yet. But basically, I took anti-aliasing and I took the screen percentage off from this. And what I mean by that, let me open my actual video settings, okay? So in the actual video settings itself, whenever you set something, like for example, you are setting or getting the shadow quality or the distance or texture quality or effects, etc., at the end you are going to use the default kind of video settings that Unreal Engine offers. Now here in this game user setting that we created, we have all the default video settings that Unreal Engine offers in terms of like blueprint interactivity. So basically, you can set resolution scale, global illumination, shadow, anti-aliasing, texture quality, post-processing, effects, reflection, etc., etc. Each of these settings you can freely edit with using only blueprints. So for example, if I go to the shadow and I go to get current shadow quality, it's using the get shadow quality. Target is game user settings and it returns a value which is the current shadow quality. Or it does the set shadow quality, which basically just a set shadow quality, and you always have to do the settings. So here settings, set shadow quality, which if you set to, I don't know, 3, that's going to be medium, this is going to be high, this is going to be epic, and this is going to be cinematic, etc., etc. So basically that's how you interact with the default settings. Now why do I say that? Is because there is one which calls scalability, which sets scalability level or get scalability level. Now these is the set scalability level, and the get scalability level in your settings also, which is going to respond to you with the actual current overall scalability level or set scalability level, which you can use to set the overall scalability level to medium, high, epic, etc, etc. Now, why this is important is because as I said earlier, I took off the anti-aliasing methods and I took off the 3D resolution from here. So I'm not allowing my users to actually set the 3D resolution and the anti-aliasing method with the overall scalability level. And exactly because overall scalability level contains this, everything, visual effects, reflection, process, etc. But also at the end, it used to contain the anti-aliasing method and used to contain the 3D resolution part. So anti-aliasing, set anti-aliasing methods, this set anti-aliasing quality, and also the screen resolution, which is just right here, set resolution based on selected resolution. So set resolution and the anti-aliasing, the set anti-aliasing, these were actually part of the set scalability level. Now what did I do is I simply took it off, and instead of doing a simple solo node like this, which sets the overall one, I do it manually with the sequencer, and I execute basically the global illumination, shadow, view distance, blah blah blah, texture, etc. Now that I'm here, I could add right here the landscape quality. So this one right here, which is the landscape quality, that's a new feature in Unreal Engine 5.4. I'm not gonna do that because as far as I know, there's no node that you can interact. So set landscape quality, yeah, there's no node you can interact with it, and either the get landscape quality. No, quads is not that one. So you cannot interact with it right now. So what you would need to do is a execute command, execute console command, and you need to type in the actual command that you can interact with it, which is going to be sg.landscape landscape quality. And that would be between 1, 2, 3, 4, blah blah blah. So it's going to be kind of similar, you know, like this node, but you actually need to do with an execute console command because that's fairly new. It's introduced in Unreal Engine 5.4, I think, this new menu, and basically you need to set your menu in order to actually set this one too. Now, of course, if you just do a set scalability, set scalability settings like this, set scalability level, and you set it to, I don't know, medium, then of course the landscape quality also going to be set by this one. But in our case, we have a custom scalability which does not set every single value, just one that we want to. So for example, it doesn't set the anti-aliasing or the 3D resolution, but that's by design because that's how we designed it. I took it off exactly because I wanted to make sure that I have complete freedom in order to create my menus. Alright, so basically we are inside the game. Now I'm going to go to back to the video settings menu. Now that we talked enough about overall scalability settings and how the quality presets work, which in our case, if I set everything into medium, that's not gonna set the resolution scaling and the anti-aliasing. Why? And that comes the part where I need some explanation. Because anti-aliasing, you can either choose a default Unreal Engine built-in anti-aliasing methods that we talked about earlier. So you can choose FXAA, MSAA, you can choose TAA or TSR, it's up to you what you choose. Each of these are going to be a built-in Unreal Engine anti-aliasers, but TSR, temporal super resolution, comes with its own upscaling methods. The other ones are not using upscaling, so without upscaling, and again, no upscaling. So, and also MSA, as far as I know, also not upscaling method, just anti-aliasers. The only upscaling method is TSR, which is the new default upscaling and anti-aliasing methods in Unreal Engine above 5.1. They studied using TSR and they never looked back to TAA anymore. Now, if you would do something custom, so for example, a AMD FSR 3.1, or you would do an NVIDIA DLSS 3.7, which is the newest DLSS, so basically you're using either FSR or DLSS. These come with their own anti-aliasing and their own upscaling methods. Now, because they bring their own anti-aliasing, because they bring their own upscaling methods, the moment you are turning your you're turning these on, they're going to override the default anti-aliaser, so FXAA, TA, or TSR. And if I would leave these menu options inside the video settings, so let's say you have an anti-aliasing method here that you can choose, and the anti-aliasing quality itself, basically, medium, high, epic, etc. That would mean that you allow your users to switch on DLSS, which gonna take over the anti-aliasing and the upscaling. So that moment, none of these are active, but you still allow your users to go into the menu, and meanwhile they're having DLSS active, they set the anti-aliasing methods to medium or low, or they set the 3D resolution also to, I don't know, 70%. Makes no sense, because DLSS, by default, it's all based on quality presets. Like DLSS has a low, medium, high, and ultra setting, meaning ultra performance, balanced, quality, and DLAA. Now these quality presets are going to dictate the anti-aliasing and the 3D resolution by itself, meaning that if I set the NVIDIA DLSS into a ultra performance mode, it's possible that the built-in anti-aliasing method that DLSS is using is going to be kind of like a low setting, and they're going to use, let's say, a 70% resolution scaling and use AI to upscale it into 100%. Meaning, you cannot set the anti-aliasing quality or the anti-aliasing itself and the resolution scaling yourself, meanwhile you are in these particular menus. That's why I separated it. That's why I took these options out from the video settings, and that's why I placed them into the graphics settings. Because I like to think about anti-aliasing in this way. The default versions from Unreal Engine, like off, so nothing, or FXA, or MSA, or TA, or TSR. And I like to also include AMD FSR and AMD NVIDIA DLSS here. And once my user turns off FSR like this, I prohibit the user from messing with the anti-aliasing quality or the resolution scaling. Why? Because AMD and NVIDIA both bring their own anti-aliasing. They set their own quality, they set their own resolution scaling, all based on quality presets. The quality presets on AMD is ultra performance, balanced, etc. So this is how you do it. And of course the frame generation. And the NVIDIA, if I go to DLSS, again, DLSS mode, ultra performance, balanced, etc. These bring its own anti-aliasing quality and resolution scaling, and that's why I removed them from the video settings menu. Now let's just go back into TSR right here. Yeah, let's go back to TSR. If I am TSR, I can, however, mess with the anti-aliasing quality. I can set this to a high, and I can set the resolution scaling, let's say around 70%. If I save this and I go out, you can see that my anti-aliasing right here is at high, meanwhile I have 70%, 66% screen resolutions. But if I would go into my menu now, and I set my quality presets, like the overall quality presets that we were talking about right here, I would set this one to a medium value, and I save this, and I go out from here. It saved everything except the anti-aliasing, which is still high, and except the screen percentage, which is still the same. I let the user manually define these values. It should not belong to the quality settings. Now, next stuff is the actual settings menu. Again, I'm using Hyper menu. This is Hyper's own menu and settings menu that I customized for my need. So basically, I added this graphics menu where user can choose an anti-aliasing and scaling solution. And depending on what he chooses, the NVIDIA DLSS section or the AMD FSR section unlocks or disables based on what you're doing. For example, in TSR or TAA or other upscaling methods, you are free to use reflex mode because DLSS reflex works nicely together with TAA or TSR. It's up to you how you use it. But once you go to, let's say, AMD FSR, I block it because reflex mode should not work with FSR because FSR have its own frame generation tool and everything, so it should not work together. But when you go to DLSS, this menu opens. So basically I set my settings menu in order to be interactive in a sense that once you turn something on or off, other settings menu are dynamically reacting to it. So if I am at DLSS, I should not be messing with the AMD section. I should not be messing with the anti-aliasing or resolution scaling settings. But once I go out for FSR, AMD FSR, I should not be messing with this one, should not be messing with this one, but I'm free to mess with the FSR section. Now, if I go to TSR or I go to TA, which is default Unreal Engine, I should be able to mess with the anti-aliasing quality and the resolution scaling, but I should not be messing with anything other than reflex mode. And that's the nice thing about this menu, is that it thinks about what the user should or should not mess with, and it blocks the certain menu items based on that. Now, how we can check if anything is applied that we actually set in the menus? Now, there's a few important things to talk about. First thing first, whenever you, let's just go first through the default anti-aliasers, okay? TA, TSR, etc. So if we exit the menu and then we do a console like this, and then we do stat GPU or GPU stats, I think GPU stat, yeah, it's stat GPU right here, stat GPU. If you do this command, you get this nice UI that basically tells what is the current GPU progress that's happening. If you need, let's enlarge it, and if you need more stuff, because there's 45 more stats, as you can see right here, if you need, you can use a command. It's called stats max per group, like this, and you can set this, I don't know, 75, so there's enough space here. Now, as you can see, there's a lot of things going on here. Now, you need to kind of know what is what in order to actually determine that your settings menu worked or not. For example, we are right now in TAA, so our basic anti-aliaser is set to TAA. So TAA right here, as you can see, has a average, a max, and the minimum value. If it does have an average, max, and minimum value, it means that it's active right now. It's working. And as you can see, it's climbing up into the stats. It's using more and more right now as we kind of, you know, go around like this on the word. It's working. It's using its stuff. Now, if we would go to our settings menu back, and let's say I do this so you can directly see what's happening when I skip the menus. Let's go to TSR, the next menu. What you're going to see, look here, the TAA going to have the average, max, and minimum value disconnect the moment I switch to TSR. Look. The moment I switched, TAA is now empty, empty, and empty, and meanwhile you can see the temporal super resolution is nicely climbing up to the actual GPU stats. It's gonna go up somewhere here. So basically, TSR now took over temporal super resolution. It does have a average, minimum, and maximum value. Meanwhile, TAA is disconnected, empty, empty, empty. If I go back from here, let's say I'm at TAA, you can see temporal super resolution is disconnected, no value, no value, no value, and TAA, you can see that it took over. It has a active value on each of these, so TAA is now our upscaling. If I go back again, now TSR is our upscaling, TAA disconnected, no values, and TSR has values. Now, this is nice, and that's how you can actually check if your setup that you did is working or not working. If you need AMD FSR or DLSS, there comes the part where we are going to actually install DLSS and FSR into the picture. Now, how we can install AMD FSR and NVIDIA DLSS is you go into the gpuopen.com, which is going to have some nice documentation. For example, the PDF guide, which if I open, it's going to have this nice long PDF documentation, which by the way, also going to have most of the commands that you're going to need. So for example, it's going to have the fidelity fx FSR enable disable command. If I bring up my little notes from here, these are all the commands that you're going to need with FSR, meaning that you're going to need the FSR r.fidelityfx.fsr 3-point-enabled 0 or 1, which turns off the FSR completely and turns on the FSR completely. You're also going to need the FI enabled 0 or 1, which turns the frame generation off or the frame generation on. And you're also going to need the quality presets, which in this case, quality 0 is the highest, most GPU intense quality preset, and 4 is the lowest quality preset. It's kind of like reverse that you used to. So usually this does not going to be like this. This is usually reverse, but in this case, ultra performance is the quality mode 4, and the native best looking is the quality mode 0. So that's all it takes, and there is the actual site here, this one, where you can download the latest version, which is always updated here. You download this version just like this, and once you downloaded it, you're going to open the folder, and the folder going to have this new release based on the engine version you have. So 5.1, 2, 3, 4, 5. Now we have 5.5, so we just select this one, and then I need to copy both of these folders. Don't worry about the rest. You have the PDF, you have some other README files, etc., patch, blah, blah, blah. You only need the FSR3 and the FSR3 movie render pipeline. And specifically, if you don't do movie rendering, you will not even need the movie render pipeline. You can just simply copy this particular folder, just like this, the whole folder itself, and you need to copy it somewhere that I show you now. Let's move into the DLSS. Now with DLSS, you need to open the NVIDIA developer site, where you have a NVIDIA DLSS section, where you click on the download now. It brings you down into this section right here. Let's just scroll it down, and the Unreal Engine 5 right here, download Unreal Engine 5.5 DLSS plugin. You click here, you accept it, and it's going to download the file for you. Now, if you downloaded this, all you need to do once you download it, same situation, you need to unzip the files that you are getting, which in our case going to be this DLSS folder. That's all the files that are inside the particular downloaded zip folder. Now inside here, you don't need any of these. All you need to go is you go into plugins folder, and you have all of these files here. What you need to do is simple. You just need to create like a new folder. Let's call this NVIDIA folder, okay? And then you just take all of these files and move it inside the NVIDIA folder. As simple as that. And then we're going to need the NVIDIA folder itself to copy it whatever we need, this NVIDIA folder, which is now going to contain all of these. Good if you also do the same with the FSR. So if you go to the FSR like this, you copy this folder from here, and then what you can do, create an AMD folder, AMD like this, and you just drop it inside. You could also drop the movie pipeline render that I said, but not necessary. If you wanna use it later on, I don't know, for that movie rendering or something, you could just also take this file and you could also just drop it inside here. So now you have two folders, AMD and NVIDIA. AMD, you got these two, and then you have the NVIDIA, which is all of these folders right here. Now what we should do with it, copy both of these things, and then you go into your Epic Games folder, you open the engine, Unreal Engine 5.5, you go into the engine folder, you go into plugins, and you find a folder which is called Marketplace. Now, if you have not downloaded any Marketplace plugins yet, what you need to do is create a new folder. So you just go new, create new folder, and name it with a capital M, Marketplace, like this. Once you open it, you can drop the AMD and NVIDIA folders just here. So as you can see, the AMD have the 2 files and the NVIDIA folder have all the files. So you just drop it here, the 2 folders that you have been created with the plugins inside them. Now, once you completed this, there's also one important thing that you need to do. A lot of people forget this and then they don't understand why it's not working. You need to go into your project settings, so Unreal Engine, your project, and you need to go to the config, and then inside the config you need to open default engine.ini. And this particular file, you need to go to the bottom of the file, so right here, and when you enable the plugins like DLSS, for example, you enable the first time, it's gonna drop these 2 lines here, which is gonna say enable DLSS in editor viewports, and it's going to set it to false. And it's also the play in editor viewport is going to set it to false by default. And a lot of people I've seen when they say, well, DLSS is not working for me, I don't see DLSS in the GPU stats and when I'm in the play editor mode, and that's because by default both of these are going to be false. Now you need to add these lines into the default engine. So be enable DLSS in editor viewports true, be enable DLSS in play in editor viewports true, and both of those inside the scripts DLSS.DLSS settings. And inside the scripts engine render settings, you need to add these. Now why I add these and what are these? This turns the whole FSR frame generation off. This turns the FSR itself off. This turns the DLSS itself off, and this turns the DLSS frame generation off. Why? When I start my engine, I do not want FSR or DLSS to be starting, because if you don't do this, both of these by default going to be fired on the moment you start your engine. It's an overhead. Both of these are going to be turned on, which is not good for the GPU. Everything should be off, and it should be loaded from the settings whenever you start the game, meaning you start the game and somewhere you stored which is your current GPU settings or graphics settings, and that's where it should be loaded. So it's good to add these particular values, and it's also good to enable the editor viewport for the DLSS. By the way, for FSR, you don't need a viewports or editor in viewports command, because FSR by default allowed to work in editor and play viewports. So that's all you need to add. But good thing is if you first start the engine, enable the plugins, restart the engine, and that's where you actually add your stuff. So you just go to your engine, the Unreal Engine, you go into edit, plugins, and then inside here, you type in FSR. You enable AMD FSR 3.1 here. You need to restart then your client. And then you need to type in NVDA. And from the many NVDA tools that you have, what you need is this one, DLSS frame generation and multi-frame generation. You need the super resolution and ray reconstruction and DLAA. This is another plugin. And if you want to add NVDA image scaling, you also need to enable that. By the way, NVIDIA image scaling is not the same as DLSS. It's part of the DLSS family, but it's basically offering a DLSS alternate version of it without the frame generation, without many stuff like ray reconstruction or resolution reconstruction or super resolution. It offers a different thing, something similar, less GPU intensive and non-GPU specific, meaning that this is the GPU agnostic version. If you don't have a RTX GPU, but you still want to have NVDA kind of upscaling, you can choose NVIDIA image scaling, which is going to be a similar to DLSS, but a non-GPU specific version, so you can run it with a low-end non-RTX GPU. But I would not recommend this one, because if you don't have an NVIDIA GPU but you still want something cool, just use FSR. It's less resource heavy and you can use in non-RTX GPUs. If you really have a low-end GPU, you might as well better off with a TSR built-in anti-aliasing and upscaling method of Unreal Engine. There's no need for you to use NVIDIA image scaling. I don't like it. Some people do. If you want, you can enable and then you can add into your settings. Also, you need the reflex. NVIDIA Reflex low latency, turn it on. You also need to have the dynamic vibrance, turn it on, and the streamline core, which is hidden implementation detail. Now you have an old streamline, which is depreciated. If you used an old project where you used before the older versions, you can use this, but because we are using on 5.5 and a brand new project, we don't need to. You just have the streamline core like this. And I do not enable a reflex here. I don't think it needs to be. It's default plugin for Unreal Engine, but we are using the dedicated reflex low latency here. So again, what you need: DLSS frame generation and multi-frame generation, SRRR DLAA, this one. You need the image upscaling if you want to have that, reflex low latency, you need the dynamic vibrance, and you need the streamline core at the bottom. That's all you need. Once you enabled it, and of course you enable the FSR, restart your engine. And before you start the restarted engine, add these commands here. So add these 6 lines of code exactly as you see it here. And that's, you save it, and then you can start your engine. Now that you started your engine, you are free to create your own kind of customized settings that you want with DLSS and FSR. And what are those settings? Let me go into my DLSS settings. So basically how I imagine this whole setting is that, like you've seen it before, I allow my users to choose what anti-aliasing methods they want, so which can be off, no upscale and anti-aliasing. In this case, I just run a r.anti-aliasing method 0, which turns off the default anti-aliaser for Unreal Engine, or fxaa, that's a method 1, or TAA, that's a method 2, or a TSR, temporary super resolution, which is a method 4. You can check this one in the Unreal Engine documentation. Each of these methods have their own anti-aliaser. So method 4 is TSR, method 2 is TAA, method 1 is fxaa. I think method 3 is going to be the MSAA. Yeah, that's it basically. And then if they choose FSR 3.1, what I do is that I do a R fidelity FX FSR enabled 1, and then I do a quality settings, which I set to quality 4, which is the lowest quality, just in case that you have a bad hardware. The moment you turn on FSR, I want you to have the worst quality settings, and then you crank it up depending how good is your GPU though. And again, if I bring up the commands here, what I do is I just do fidelity FX FSR 3 enabled 1. So I turn on the FSR setting itself. So this is right here, is this right here, not sorry, yep, like this. So this FSR 3 enabled 1 is this FSR 3 enabled 1, which is just turning the FSR on itself. And then I set the quality to 4, which is the lowest, because 0 is the highest, most GPU intense quality preset. I set it to the less GPU intense quality preset, and that would be the time where you could actually, let's say, turn on or off the frame generation. So FI enabled 0 or 1. So FI enabled 0 or 1, this is the frame generation. In my case, whenever they just turn on the FSR, I don't care about frame generation. It's a separate tool. They can turn it on if they want to. By default, that's, as far as I know, it's off when you turn on the FSR. But if you want to, you could just put it here and you either turn FSR also on or off depending on what you need. But this is what you interact basically with FSR. And whenever you turn it off, all you need to do is you set this one to 0. Yeah, because you're turning it off. You also set the frame generation to 0 because you're turning it off. And then you could set, you don't need to set the quality because you turn it off, so the quality doesn't matter anymore. So turning it on is enabled 1 and setting a quality preset. Turning it off is enabled 0, don't care about the quality. And that's also the FI enabled 0 or 1, meaning it's either using frame generation or doesn't use frame generation. For the DLSS methods, so once they turn on DLSS, there is many different blueprint components that you can actually use in order to work with DLSS, because DLSS have the streamline core that we just enabled, so it has a bunch of different stuff. I saved a few DLSS mode here, meaning that it has a is DLSS SR enabled, super resolution, is DLSS RR enabled, resolution ray reconstruction. Well, it says resolution reconstruction in online, but it says ray reconstruction here, whatever. Is DLSS SR supported or RR supported? These are also just Boolean checks if it's supported or not. You can enable SR, you can enable RR, you can get the current DLSS SR mode, like you can get the DLSS SR mode information, meaning that let's say on balanced mode, what is the minimum screen percentage, what is the fixed screen percentage, what is the optimal sharpness, so you can actually get values out of it and determine what is what, you know. You can also just do a get default DLSS mode, meaning it's going to find a reasonable default DLSS mode based on the current hardware, which is going to return either a off, auto, DLA, ultra quality, quality, balance, performance, ultra performance. So there are a few nodes that you can work with. In our case, what I do is I simply do is DLSS SR mode supported, and I check if ultra performance is supported, so the lowest actual set is supported. By the way, you could just do this, that's also the same thing. You could just do like this, is DLSS SR supported. You could also check for is DLSS RR supported, which I would not do because resolution reconstruction or ray reconstruction is an extra feature of DLSS, which you can turn on if you want to, but super resolution is automatically comes with DLSS. So if SR is not supported, not enabled, sorry, what is it? SR supported right here. So if SR is not supported, then DLSS not supported whatsoever. Because is DLSS SR mode supported node, if you set it to ultra performance, this is the same that you would run a is DLSS SR supported, which checks if any of these quality sets are supported whatsoever. Again, SR is the default super resolution, which comes from any of these particular sets. So if SR is not supported, then the user hardware does not support DLSS. So what I do is I check for is DLSS SR supported. If it's not, then I just set back my UI settings menu back into the previous value and I say DLSS is not supported. If it's supported, then I say, okay, DLSS is supported. This is just turning off AMD, it doesn't matter. And what I do is there is this set DLSS DLAA mode, no auto, set, so set DLSS DLAA mode, and you have the auto and the no auto mode. I do no auto mode, and inside here I'm able to set it off, auto, DLA, ultra quality. Good to mind that ultra performance, performance, balance, quality, and ultra quality, you just do it like this. But when you set it to DLAA, you need to do like this. DLA enabled, yes. So you need to set it like this. That's all you need to remember. Now, whenever someone turns on the DLSS settings, I set it to ultra performance because I care about the GPU, the hardware. Because if I set it to quality, ultra quality, whatever, it's possible they're turning it on, but the GPU only support up to balanced. So it's good to start with ultra performance and let the user crank it up and then see how far they can go and then do by that. By the way, you could theoretically also do this where you have this set DLSS mode. You do like this and you do a select element like this. Okay, let me just actually copy this one right here. It's already set up. You do a select element like this, which going to return the default DLSS mode. You go in like this, sorry, the select not connected here, true. You get the default DLSS mode. So get default DLSS mode, this here, get default DLSS mode, and you just connect it here. Meaning, once the set DLSS DLAA mode is triggered, it's not going to set to ultra performance, but it's actually going to read from the current hardware, which is the optimal solution, and is going to set to that. And then once it's set it, I could, the next where I have to set my menu indexes, wherever they're supposed to be, I could just do like this, get default DLSS mode, onto a select element, and the return value, I could use it in the indexing. So set my DLSS option, like for example UI setting action DLSS mode. Here it sets to 1 because 1 is ultra performance, but I could just theoretically do like this, and instead of setting it to 1, it's what it's going to do is set the DLSS DLAA mode based on the current hardware, and then it's going to set my menu the slider status depending on wherever it's set from the current hardware. So meaning that if here, like here, it's set the DLSS mode, let's say in a, I don't know, balanced, for example, then here I'm going to get the balanced, which is 3, and it's gonna set my index to that value. So that's also working. I had some issues, however, with this, because when I did this, this get default value, it's set to auto. And if it's an auto, I cannot set my index state to auto because I have my index set at either DLA, ultra quality, quality, balance, performance, ultra performance. I don't have an auto set for it. So, but if you have an auto set for it, you could do that too, and it sets to auto, whatever. I just show you a way that you dynamically can set the DLSS DLAA mode based on the current hardware, and you can actually get whatever this has been set on with the select element, which returns an integer, to set your menu slider state depending on whatever set pin here. But that's all it takes, and further on, whenever the DLSS is turned into a given quality preset, you can also further debug it, saying that is DLSS RR mode supported? Is DLSS RR mode enabled? If yes, you can set your UI to set the RR enabled. If not, set it to false, whatever is up to you. So you have many options here that you can work with DLSS, meaning you can check it if it's enabled or disabled, RR/SR. You can check if it's supported, RR/SR. You can enable RR/SR yourself, or you can just do information for the given quality presets, as well as determining the current hardware-based optimal quality preset. And of course, you can set it with the set DLSS DLAA mode no auto to your given preset or DLAA, but that case you also need to tick this DLAA enabled. That's all it takes. And whenever we go a little bit down, I have the particular menus. So we're not just selecting here a option, whatever you want to, but we also have an NVIDIA section and an AMD section. Let's go through that, okay? So the AMD section, it has just two settings, which is a frame generation right here, which can be either a fidelity FX FI enabled 0 or 1, same that we had in the code here, frame generation disabled, frame generation enabled. So it's AMD's frame generation either on or off. That's all it takes. Now the quality presets, same situation I showed earlier. 0 is the highest, most GPU intense quality preset, and 4 is the lowest. And you can go between 4 and 0 depending on what quality presets you like. So quality preset, quality 0, 1, 2, 3, 4, which is going to be up from 4, ultra performance, performance, balanced, quality, ultra quality. And then you just update the state of your slider depending on whatever it's been selected. That's all it takes for the AMD. You set the quality of the presets and you set the frame generation. Now for the NVIDIA is a little bit more stuff. So if I zoom out, I can show you that there is more stuff here than just like the NVIDIA, which is really small one. Let's start with the obvious one, which is the quality presets. Now I have the quality presets, which is you can also check it. So let's say is DLSS SR mode supported right here. Now what these do is that you can check if the DLAA mode supported, ultra quality supported, balance, performance, or ultra performance supported. Meaning instead of you directly forcing a DLSS set, let's say setting it to ultra quality, meanwhile you know that your user's hardware is not capable of executing it, which is going to crash out your game and possibly gonna hurt the GPU. Instead of doing that, what you can do is check the is DLSS SR mode supported, check if the given quality mode that you're trying to trigger with your settings is supported or not. And if it's not supported, I set back the UI state to previous value. But if it's supported, true, then what I do is I simply set it to that particular stuff. So set DLSS DLAA mode, same that we did above. Set ultra performance, performance, balanced, quality, ultra quality, or DLA. If it's DLA, we do DLA enabled. That's all the quality presets, and I check every single time if the given preset is supported or not. It's a good, with a nice switch on int basically, and I do that whatever the state of the settings slider, that's based on whatever you want to do with it. Reflex, this is cool. So NVIDIA Reflex, basically what I do again is NVIDIA Reflex supported. You got these nice nodes that you can check if the reflex mode is supported or not. If it's supported, set the reflex mode based on the index itself, which can be off, enabled, or boost depending on what is the index. We're setting the reflex mode itself. And then I log that it's updated. If it's not supported, reflex mode, then I do some precautions. If not supported and user trying to turn it on, I set back the index to the previous value without saying. So let's say it's off, you are turning it on with the slider. I take back the slider into off because I do not allow you to turn it on if it's not supported by your hardware. If it's not supported but somehow was on, so it was 1 but user trying to turn it off, I allow it to turn it off with the set reflex mode fixed off. These are just, precautions that if somehow something happens, The next one, RR resolution reconstruction. Now, this is optimal. User can turn it on or off depending if he wants to. If you enable DLSS by default, this is off by default. It's not turned on, but you can turn on if you want to. Again, is DLSS RR supported? Right here, you can check if it's supported. If it's supported, yes, then I do a boolean because the node itself enabled DLSS RR, DLSS RR is either like this, enabled or not enabled. That's all it takes, and I have a 0 or 1 state of my integer of my if my slider, which says on or off the RR, and if it's on, I set it on. If it's off, I set it off. Obviously, if it's supported. If it's not supported, again, if not supported but user trying to turn it on, set back the index without saving, and I also say RR not supported on this current hardware or environment. And then if it's not supported but somehow was on, let user disable and save of status. Either way, again, precautions, just my OCD, making sure that I never lose state of my actual menu. Next, frame generation. There comes the funny part. NVIDIA frame generation, which can, in the old frame generation, which is the older versions for RTX 3000 cards and 4000 cards, it was either an off or an on. You either off or on. And if it's on, it's on. If it's off, it's off. But in the new version for RTX 5000 cards, it's a either off, auto, 2x, 3x, 4x. Now what I do here is first I check if NVIDIA FG in general is supported or not. If it's not supported, again, precautions, if it's not supported by user trying to turn it on, index backs, no save. And if it's not supported but was on, disable and save status. But if it's supported, so NVIDIA DLSS FG is supported, again, you can check it with NVIDIA DLSS FG supported like this. If it's supported, I also check a conditional check. Is the DLSS FG mode supported? As you can see, there's a difference between them because the mode supported is basically checking if any of the specific modes are supported. And now what I do is, let's say you are trying to set this to option 4, which is 4x. This is just on RTX 5000 cards. Now, if you're trying to do this, I conditionally check if it's actually supported by your GPU. And if it's true, then I allow you to set it to your desired state. But if it's not, then I take back the index of the settings menu, so the slider, in a previous value, so -1, and then that's all I do here. So, but if it's supported, sure, I allow you to set it. And then I also check if it's off or not, because if it's off, I do other stuff here. Now, good thing to know that once you turn on frame generation, so either of these, auto 2x, 3x, or 4x turned on, reflex, NVIDIA reflex automatically will be turned on to a state of on plus boost. So let's say I switch this one to 2x right here. If I go back to reflex right here, it's either off, enabled, or boost. Now, if you turn on frame generation, this automatically goes into boost. And because it automatically goes into boost, I need to update my setting state or index of the setting state, meaning that once you set it to anything other than 0, so auto 2x, 3x, 4x, I also update the NVIDIA reflex slider basically, and I set the NVIDIA DLSS reflex slider into 2, which in our case was a boost state. So meaning that it's not equals to 0, so you are turned on the frame generation 2x, 3x, 4x, so we are automatically turning the reflex to a given state. And that's all it takes. Let me go and show it in reality how it looks like. So if we go into the game, and we open the menu and we go to graphics and I enable DLSS. Let's just first open our, let's actually go to DLSS. If I open frame generation, as you can see, the DLSS reflex mode is on plus boost, so it's index 2. Why? Because frame generation brings the reflex by itself. It's not optimal. You cannot mess with it, like turn it off, turn off reflex. No, reflex has to be on when frame generation is working. That's what I said. You need to understand how these things are working when you add it to your game. Otherwise, you're quickly going to lose state of where these settings should be actually in the game. Because you let user turn on frame generation, meanwhile the reflex mode says off, and then you lost state because reflex mode actually wasn't off, it was on state 2, which is on plus boost, but you did not show it to the user, so you lost state of where the actual UI is. That's why everything interacts with each other. Now let's go back into the TSR. So right now we have TSR. Okay, let's just save this one. And let's just run start GPU. So we can see, we should be seeing that temporal super resolution right here on the top of the line has the max, min, and average, so it has values. That's our anti-aliaser. Now if we turn on AMD, let's just do it like this. Now you can see temporal super resolution disconnected, no values, and you can see that fidelity FX super resolution 3 pass, and also the FSR 3 dispatch is climbing up on the GPU task list or stat list. Basically, this is the two things that are going to be enabled whenever you're using AMD FSR. So fidelity FX super resolution 3 pass, and also the fidelity FX FSR 3 dispatch. These two are AMD FSR. These are going to be always active when you have FSR active. If I would go back, both of these are disconnected, no value and no value, and you can see the temporal super resolution is back and it has value. Let's go back again. Now temporal super resolution disconnected, and FSR has both of these and these active. Now if I go to DLSS, you're gonna see that both of these disconnected, fidelity FX super resolution disconnected, temporal super resolution TSR disconnected, and you can see that DLSS is starting to climb up on the task list right here, DLSS. This is just a single line, DLSS, that's all it takes. And if you see this active, it means your DLSS is currently active. Now, if I close this one, if you set your frame generation, resolution, reconstruction, etc. reflex mode, they're not going to be showing in the max stats or stats GPU, so you have no real way of tracking their status other than your settings. So if I go to max stats, all I'm going to see is DLSS if the DLSS is active currently. But the max stats, this is how you track if actually your settings is correct or not. But you can also track if they active any of these, so frame generation, resolution, reconstruction, reflex mode. You can try by going into your graphics settings, and inside you can use the ease DLSS RR enabled, or you can do ease DLSS SR enabled. So you can check if the super resolution enabled, you can check if the RR enabled. And by the way, when it comes to, let me just quickly go here. When it comes to the DLSS mode, so quality, presets, performance, balance, quality, ultra quality, etc., why I'm not using a super resolution, so enable SR, yes, enable SR, because SR is automatically enabled by these. These are themselves SR. A lot of confusion about the space. Whenever you set enable, disable DSSR super resolution slash DLAA to set a DLSS SR quality mode, set an approximate upscaling. You see, to set a DLSS SR quality mode, meaning that you set your quality mode here. The moment you set any of these quality modes, SR is automatically turned on. You do not need to worry about SR. That's why I don't add it into my menu, a separate slider for SR, because SR itself is the quality menus themselves. Yeah, so that's all it takes. So that's how I built my settings menu, the basic anti-aliasers, AMD, DLSS, and inside AMD and DLSS also submenus where you can set the frame generation and the quality presets for AMD, and you can set the quality presets, you can set the reflex mode, the frame generation, and also this resolution reconstruction for NVIDIA. That's how I built my DLSS menu, and that's how I made it interactable. I hope that helped someone. I hope that helped you clear out what is the different anti-aliasing methods, upscaling, etc., and give you a good grasp of how you should set up your settings menu. Take care, guys. See you at the next one.